Ever wondered why we have day and night? Why does the sun seem to move across the sky? Have you ever pondered over the magical transformation from dawn to dusk, and how our world plunges into darkness only to be illuminated once again? Or perhaps you've questioned the reason behind the changing lengths of days and nights. Well, the answers to these questions lie in the fascinating science of the Earth's rotation and its relationship with the sun. The Earth spins around an imaginary line that we call its axis. This invisible line runs from the North to the South Pole, and it's this axis that the Earth spins around. Much like a spinning top or a child's merry-go-round, our planet is in constant motion. But why does the Earth spin? Well, it's all down to the way our planet was formed over 4.5 billion years ago. When the solar system was a young, chaotic place, a massive cloud of gas and dust began to collapse under its own gravity, forming the sun at its center. The remaining material began to spin faster and faster, eventually flattening into a disk from which the planets, including Earth, were born. The initial spin from this cosmic dance has been preserved, and that's why Earth continues to rotate. Now, this rotation isn't just a fun space fact, it's crucial for life as we know it. You see, as the Earth spins on its axis, different parts of the world face the sun. When you're on the side facing the sun, it's day. But as the Earth continues to spin, your part of the world turns away from the sun and it becomes night. This spin is also why a day lasts 24 hours. It takes that long for the Earth to complete one full rotation on its axis. If the Earth spun faster, our days and nights would be shorter. If it spun slower, they would be longer. But here's a fun fact. The Earth doesn't spin at a constant speed. It actually spins slightly faster at the equator than at the poles. This is due to the Earth's shape. It's not a perfect sphere, but an oblate spheroid, meaning it's slightly wider at the equator. So the Earth's rotation is responsible for the change from day to night. But what about the sun's movement? You might have noticed the sun moving across the sky, but is it really moving? This is a question that's puzzled many of us at one time or another. The sun appears to rise in the east, reach its peak in the middle of the day, and then set in the west. But what's truly happening is a celestial dance between our planet and the sun. Let's put on our imaginary space helmets and delve into this intriguing phenomenon. The sun's apparent motion across the sky is, in fact, an illusion. Yes, you heard that right. It's an illusion created by the rotation of our home planet Earth. Imagine you're standing on a spinning top. As the top spins, you would see the world around you whirl by. But of course, it's not the world moving. It's the top you're standing on that's spinning. This is similar to what's happening with the Earth and the sun. Earth rotates on its axis, an imaginary line that runs from the North Pole to the South Pole. And it does this rotation from west to east. This is why, when we look up at the sky, the sun seems to move from east to west. But just like the spinning top, it's not the sun that's moving, it's us. This west to east rotation of the Earth takes about 24 hours, giving us our day and night. When the sun appears to rise, it's actually the part of Earth you're on that's rotating towards the sun. And when the sun appears to set, that's your part of the Earth rotating away from the sun. So next time you're enjoying a beautiful sunrise or sunset, remember that it's not the sun that's moving across the sky. Instead, it's the Earth, our rotating home, that's providing us with these spectacular daily shows. So it's not the sun that's moving across the sky, but the Earth that's spinning on its axis. Now you might be wondering, how does the Earth's rotation relate to the sun? Well, let's delve into it. While the Earth spins on its axis, creating the cycle of day and night, it also embarks on an epic journey around the sun. This journey, or orbit, takes a whole year to complete, and it's this annual journey that gives us the changing seasons. Imagine Earth as a spinning top, making its way around a light bulb. That's our sun. But the Earth's path around the sun isn't a perfect circle. It's more of an ellipse or a slightly stretched circle. This means that the distance between the Earth and the sun changes throughout the year. But here's a fun fact. It's not this changing distance that causes our seasons. Instead, it's the tilt of the Earth's axis. As Earth orbits the sun, its axis always points in the same direction. So at different times of the year, different parts of the Earth get the sun's direct rays. For example, when the North Pole tilts towards the sun, it's summer in the northern hemisphere. The days are long and the sun is high in the sky. Meanwhile, it's winter in the southern hemisphere, with shorter days and lower sun. 6 months later, the situation is reversed when the South Pole tilts towards the sun. This tilt and the resulting sunlight distribution gives us the 4 seasons: spring, summer, autumn, and winter. Each season brings its own unique weather patterns and length of daylight. So, to sum up, the Earth's rotation on its axis gives us our day-night cycle. And it's the orbit around the sun combined with the tilt on its axis that gives us the changing seasons and the variety in our climate throughout the year. It's a beautiful and intricate dance between the Earth and the sun, a dance that's been going on for over 4.5 billion years. So, it's the Earth's rotation and orbit around the sun that gives us our daily and yearly cycles. So, let's sum up what we've learned about the rotation of the Earth and sun. The Earth spins on its axis, an imaginary line running from the North Pole to the South Pole. This rotation is what gives us our daily cycle of day and night. As the Earth spins, only one half of it faces the sun at a time. The half that's in sunlight experiences day, while the half in shadow experiences night. This rotation happens once every 24 hours, which is how we've come to define a day. Meanwhile, the Earth is also on a yearly journey around the sun, following a path known as its orbit. This orbit isn't a perfect circle, but rather an ellipse or slightly stretched out circle. Now here's where things get interesting. The Earth's axis isn't straight up and down, but tilted at an angle of about 23.5 degrees. This tilt, combined with the elliptical orbit, is what gives us our seasons. In summer, the tilt of the Earth's axis means that the sun's rays hit part of the Earth more directly, causing warmer temperatures. In winter, the tilt angles the Earth away from the sun, so the sun's rays have to travel further to reach us, and the temperatures are cooler. In between these extremes, we have spring and autumn. During these seasons, the tilt of the Earth is such that the sun's rays hit the Earth at a more intermediate angle, leading to milder temperatures. Now, let's not forget the sun's apparent motion. As the Earth rotates, the sun appears to move across the sky from east to west. This is why the sun rises in the east and sets in the west. But remember, it's not the sun that's moving. It's the Earth's rotation that makes it seem that way. And finally, the sun too rotates. It spins on its axis just like the Earth. But because the sun isn't solid like Earth, different parts of it rotate at different speeds. This differential rotation plays a key role in generating the sun's magnetic field. So there you have it, the fascinating science of the Earth's rotation and its relationship with the sun. Isn't it amazing how these celestial movements shape our daily lives?